Айгер, можете дать мне разрешение на запись?
У вас есть передовик тону?
Все есть. Всё.
So let's start. Dear members of the Dissertation Council, dear attendees, the quorum of the meeting of the Dissertation Council is the specialties: physics, nuclear physics, technical physics, physics and astronomy, radio engineering, electronics and telecommunications, material science and technology of new materials, thermal power engineering, and physics educational, standardization and certification by industry at Al-Farabi Kazakh National University on April 11th, 2023 is available. At the meeting of the Dissertation Council, 12 out of 12 members of the board. The minimum quorum to start the work of the council is 8 people. So let me to read members. Medeo Abishov, Farida Belisarva, Zainullah Janabayev, Karlagash Jumagulova, Saltanat Bulegenova, Alexander Arbuz, Evgenia Dayneko, Vanshbek Shunkeev, Sergei Zaitsev, Viktor Bruce, Farabi Bojev, and Didar Batrashev. So I read all of our members, all of them here. So let's start our work. Someone has any objections about starting? Thank you. So the meeting of the Dissertation Council is declared open. So everyone has an agenda in their hands. So on the agenda is a thesis of the thesis defense of Tulugenova Malika Askarovna on the topic anti-corrosion protective coating based on graphene nanostructures. For the degree of Doctor of Philosophy in the specialty 6D071000 Material Science and Technology of New Materials. The thesis work was carried out at the Department of Solid State Physics and Nonlinear Physics of the Faculty of Physics and Technology of Al-Farabi Kazakh National University. Scientific consultants: Ilyin Arkady Mikhailovich, Doctor of Physical and Mathematical Science, Professor of Al-Farabi Kazakh National University, Almaty, Kazakhstan. And foreign supervisors: Gary Wayne Beale, Doctor of Physical Chemistry, Professor of Texas State University, San Marcos, USA. Official reviewers: Harbuz Alexander, PhD, Coordinator of the Research Infrastructure of the Share of Nazarbayev University, Astana, Kazakhstan. Evgenia Dayneko, PhD, Associate Professor, Vice Rector for Science and International Affairs, International University of Information Technologies, Almaty, Kazakhstan. Official reviewers are present. This is them. Okay. The thesis of work is submitted for defense for first time. All members of the Dissertation Council have materials on this work. Do council members have any comments on this agenda? If no, the agenda was approved by this. To get acquainted with the personal file of the dissertation, the floor is given to the scientific secretary of the Dissertation Council, candidate of Physical and Mathematical Science, Belisarva, Farida Beksultan.
Thank you. Dear members of the Dissertation Council, let me acquaint you with the materials received by the Dissertation Council from the applicant Tulugenova. An application addressed to the chairman of the Dissertation Council on the acceptance of the thesis for defense, thesis in hardcover and on an electronic media. Information about the doctoral student Tulugenova Malika, Kazakh born in 1993, place of birth Almaty. She has a higher education. In 2015, she received a bachelor's degree in material science and technology of new materials. In 2017, she received a master's degree in material science and technology of new materials at Al-Farabi National University. A personal sheet certified at the place of study, a copy of the bachelor's and master's diploma with annexes, a copy of the transcript certified at the place of study, reviews of domestic and foreign scientific consultants certified at the place of work of consultants, extract from protocol of the meeting of the department approved by the vice rector for scientific and innovative activities of Al-Farabi National University, and an attendance sheet, reviews of official reviews, certificate of the National Center of Science and Technology Evaluation for Anti-Plagiarism, certificate of issuance of the thesis and notation from the Scientific Library of the Al-Farabi National University, start from protocol of the meeting of the Academic Council of Al-Farabi National University on the approval of the topic of the thesis and scientific consultants, a copy of the order of the rector of the Al-Farabi National University on the direction of defense thesis, a list of scientific works certified by the scientific secretary of the Faculty of Physics and Technology of Al-Farabi National University and their copies, based on the results of the thesis work. 7 printed works were published, 3 of that were published in journal included in the database dictated by Scopus scientific databases, 1 in international journal, 3 in the journals included in the list recommended by the Committee for Control of Education and Science of the Ministry of Education and Science of the Republic of Kazakhstan. Materials of the thesis submitted by the applicant Tулегенова М comply with the proved rules for the preparation of the thesis for defense by the Committee for Quality Assurance in the field of science and higher education of the Ministry of Science and Higher Education of the Republic of Kazakhstan, admitted to the defense.
Thank you. So, have anyone some question for scientific secretary's information about the applicant? So, there are no questions. So, what is provided to describe the main content of the thesis of Tулегенова Malika up to 20 minutes. So, Malika, please, floor is yours.
Topic of my thesis work is anti-corrosion protective coatings based on graphene nanostructures. The relevance of this study. One of the important technical, constructional, and economic problems of our time is the protection of materials and products from the effect of aggressive environmental factors, which include mechanical action, chemical effects of gases and liquids, high temperatures, as well as radiation of various kinds. Ideal defect-free graphene film is capable of becoming ultra-thin and effective anti-corrosion coating because of their chemical inertness and impermeability. The purpose of this thesis is the theoretical and experimental study of the effectiveness of anti-corrosion protective coatings based on graphene nanostructures under the influence of external factors. The task of the thesis are computer simulation of graphene nanostructures, calculation of the efficiency of their anti-corrosion properties using first principle methods, development of technology for obtaining coatings based on graphene nanostructures on the surface of copper and nickel for corrosion protection. The study of the protection efficiency of the obtained coatings based on graphene nanostructures by energy dispersive X-ray spectroscopy under the influence of various external factors. Development of specialized OJ analyzer for the analysis of ultra-thin layers of anti-corrosion protective coating based on graphene nanostructures. The main provisions for the defense of the thesis: ideal graphene's structural defects in the form of vacancy, deep vacancy, and a small gap in the sheet have a high efficiency of protective effect against oxygen penetration due to the formation of potential barrier with the oxygen molecule interacts with the surface of the graphene layer. In the graphene sheet with sufficiently large gaps.
Malika, your presentation is still.
What?
Your presentation doesn't work, I think, because you.
Sorry, я переключаю.
Yeah, we see only the first slide. Doesn't move.
Интересно. Sorry. У меня есть. Я переключаю на своем компьютере. Получается, у вас не переключается. Да?
Перезайдите просто.
Да, у всех не
We have a problem.
Technical problem. We have a technical problem. Sorry for it. Так. And now?
Ну, перелистайте, она стоит еще.
Перелистайте. Sorry.
Может, у вас два варианта, а вот теперь.
Нет, у меня одна. Вот она стоит.
Хорошо, все,
F5 не работает, да, Малика? F5 не работает?
F5 я вот включаю, F5, и дальше вот листаю F5. Не проходит как.
Еще раз F5 сделайте, когда он переключится на него. Ну-ка, перейдите на третью страницу.
Да?
Нет, не переключается.
Не переключается.
Еще раз F5.
Можно я сейчас перезайду? Может попробовать перезайти?
Нет, нет. Сейчас запись идет же.
Что до этого нормально? Ну-ка. Now.
Давайте переключайте.
Теперь, да, дальше.
Ага, все.
Все? Так, я stopped this slide. Anti-corrosion slide forward. In the in the graphene sheet, with sufficiently large gaps, the methods of high efficiency of protective against effect against oxygen penetration is achieved by its functionalization with impurity gallium atoms due to the formation of a strong gallium carbon covalent bond and a high oxygen absorption energy of gallium. Anti-corrosion graphene coatings obtained by chemical vapor deposition demonstrate reliable protection of copper and nickel surface from thermal corrosion, which is associated with the high quality of the coatings. OJ spectrometer designed and implemented using the conical phase field electrostatic energy analyzer allows to control both small and large areas of anti-corrosion graphene coating, as well as their structures in situ. Figure 1A. Figure 1A shows computer simulation of oxygen molecule passing directly through graphene. For the possibility of oxygen penetration through the gap between the substrate and graphene, two basic orientations of the oxygen molecule when entering the gap were considered in figure 1B. The axis of the molecule is parallel to the graphene edge, and the axis of the molecule is perpendicular to the graphene edge. Figure 2A was used as a model gap in the coating between two graphene sheets, which had a width of 0.25 nanometers. Figure 2B shows the computer models used to calculate the energy characteristic of the configurations of oxygen molecules approaching the gap in the coating. Figure 2C presents pictures of the electron charge distribution at a density of 10 electrons per nanometer cubed. This density roughly corresponds to the characteristics of the electrons in the conduction band. The calculation results in figure 2DE show that in this configuration, oxygen doesn't penetrate through the gap in the graphene coating to the protected surface. Computer simulation and calculations show the presence of high energy barrier when the oxygen molecule penetrates through graphene containing defects. The results of calculations of the energy barrier depends on the orientation of the oxygen molecule when the oxygen molecule penetrates through defects in the graphene are presented in the table 3. Provision 1. Ideal graphene with structural defects in the form of vacancy, devacancy, and small gap in the sheet have a high efficiency of protective effect against oxygen penetration due to the formation of a potential barrier when the oxygen molecule interacts with the surface of the graphene layer. Next, figure 4A shows a computer model of the cluster of 4 gallium atoms that emerged after adsorption on the graphene surface. The results of the simulations and calculations presented in figure 4b and 4c show that the bonding of the cluster with the ideal graphene is not strong enough, which is confirmed by the absence of dense electronic bridges between the cluster and graphene at the maximum charge density corresponding to the formation of bonds. In this part of the work, the possibility of maintaining the effects of the protective coating in the presence of sufficiently large gap in the graphene sheet with a size of 0.45 nanometers was investigated. The linear structure of gallium atoms is used as blocking elements. Figure 5a and 5c illustrate the results of calculations of the electron charge distribution with configuration optimization for the merged linear structure of gallium atoms connected with the edges of the graphene protective coatings. It's clearly seen that between gallium atoms and the graphene sheets at a high charge density, the electronic bridges appeared, indicating the formation of covalent bonds. Figure 5D shows a computer model of the configuration that occurs when an oxygen molecule adsorbs on a linear structures of gallium atoms. It was of interest to find out the change in the character of the protective coating, gap blocking when the gap size changes. In the figure 5e, shown oxygen molecule adsorption zone element on the blocking chain at a gap width of 0.25 nanometers. The data presented in the figure 6 indicate a significant rearrangement of the configuration blocking the chain gap. But the characteristics of chemisorption capture of oxygen molecules at the gap boundary are actually fully preserved, as evidenced by the electron charge distribution maps, and the protective ability of the graphene protective coatings remains effective. Provision 2. In the graphene sheet with sufficiently large gaps, the maintenance of high efficiency of protective effect against oxygen penetration is achieved by its functionalization with impurity gallium atoms due to the formation of a strong gallium-carbon covalent bond and high oxygen absorption energy of gallium. In this part, the technique of CVD synthesis of the graphene coating in a sealed flow tube with the diameter 80 millimeters was developed. Argon-hydrogen mixture was passed as a buffer gas, and benzene vapor was used as a carbon source. Figure 7a shows the appearance, and figure 7b shows the scheme of the CVD installation. The graphene synthesis process is shown in figure 8a. Figure 8b shows CVD graphene on the nickel after synthesis. Figure 8c shows the Raman spectrum of the graphene coating after transfer to a dielectric substrate. Figure 9 shows electron micrographs of nickel foil after graphene synthesis. Analyzing the microphotograph in figure 9a, we can see the boundaries of the nickel grains and estimate the average size, about 130 micrometers, which in the growth process determines the average lateral size of graphene. Few layer graphene nanostructures were then formed on the surface of the copper using the CVD. Figure 10 shows the Raman spectrum, confirming the presence of a few layer graphene on the copper surface. This was followed an elemental analysis by EJS of samples of copper and graphene-coated copper. The next step was the oxidation of copper and graphene-coated copper at 300 Celsius degrees for 30 minutes in the air atmosphere. The oxidized samples of copper and graphene-coated copper have been analyzed by EDS. Table 4 shows the EDS results before and after oxidation. Elemental analysis of the obtained samples showed that the graphene film was able to reliably protect the copper plate from oxidation. Next. Figure 11. Figure 11. In figure 11, we see optical micrographs of copper and graphene-coated copper after oxidation. Copper, in contrast to graphene-coated copper, acquired a characteristic red-brown color of cuprous oxide. Next. Few layer graphene nanostructures were ground on the nickel surface by the CVD method. Figure 12 shows the Raman spectrum, confirming the presence of few layer graphene on the nickel surface. The next step was the oxidation of bare nickel and graphene-coated nickel at temperatures of 300, 400, 500 degrees for 10 minutes in air atmosphere. The obtained samples were analyzed by EJS. Based on the quantitative composition of oxygen shown in figure 13a, we determined that graphene-coated nickel at a temperature oxidized slower than bare nickel. Figure 14 shows optical micrographs of bare nickel and graphene-coated nickel after oxidation. Micrographs clearly show traces of corrosion after heat treatment. Provision 3. Anti-corrosion graphene coating obtained by chemical vapor deposition demonstrate reliable protection of copper and nickel surfaces from thermal corrosion, which is associated with the high quality of the coatings. Figure 15a-b presents calculated models of analyzers with point-to-point focusing, but the analyzer shown on figure 15b has the point source and focus on the axis of symmetry, and focusing length f is equal to the distance sf. The calculated structure of potential lines doesn't show any noticeable fringing field effect between electrodes. The 15A system allows to analyze surface of any remote object and to get the average data over some surface area. The 15B case allows the point probe application for exploration of a remote object or scanning some small area. Typical, this slide shows typical aberration figures, and in figure 16 shown the second order focusing for both analyzer configurations. Next. Figure 17 presents the results of model calculations of an energy transmission function for both analyzer configurations. Light asymmetry is possibly caused with a complicated shape of these electrostatic fields, which is more related to the configuration presented in figure 15B. Next. Figure 19 shows a typical experimental OJ spectrum obtained when testing a new energy analyzer on a stainless steel substrate, which indicates the high resolution of the analyzer. The fine structure of carbon OJ peak is clearly visible. Figure 12 shows the practical results obtained by using the useful properties of the analyzer, in particular the possibility of modifying the front electrode. A system for growing graphene nanostructures was implemented in the analytical ultra-high vacuum chamber of the OJ spectrometer. Growth was carried out by diffusion of carbon through nickel foil, followed by controlled formation of fuel layer graphene nanostructure from the side of the analyzed surface. Figure 12A shows the OJ spectrum obtained from nickel foil after annealing in an ultra-high vacuum chamber. Figure 20B shows the Raman spectrum of the same sample, which confirms the presence of pure royal graphene nanostructures. OJ spectrometer designed and implemented using the conical phase field electrostatic energy analyzer allows to control both small and large areas of anti-corrosion graphene coatings, as well as their structures in situ. Conclusion. As the thesis work was carried out, the computer models were created as the calculation of the barrier properties of graphene against oxygen penetration were performed using the commercial software program DEMO3. The computer simulations and calculations showed the presence of a high potential barrier for the oxygen molecule penetration through the graphene, even in the presence of structural defects. Computer models and quantum mechanical calculations show that the functionalization by gallium atoms of the graphene coating, which has a sufficiently large gap between the sheets, retains the ability protection due to a significant reconfiguration of the gap blocking chain of gallium atoms and their high chemisation ability to capture oxygen molecules. During the implementation of thesis work, way of production of graphene by CVD has been worked out. The result of a comprehensive study of the obtained samples of graphene using Raman spectroscopy, electron microscopy, EDS, and optical microscopy show the high quality of graphene. The results of the study of the elemental composition of the obtained CVD graphene samples show reliable protection against temperature corrosion. Numerical calculation of focusing properties of a new type electrostatic energy analyzers on the base of a conical phase field were carried out. The results demonstrated sharp enough second order focusing as well as the good acceptance characteristic by analyzing remote objects of different shape and sizes. Due to the simple and convenient design, this energy analyzer allows to analyze the graphene nanostructure directly in the growth chamber. It's in this slide shown my list of publications. You can see. And this list of publications. 3 articles were published in journal included in the Scopus database. 3 articles were published in journals recommended by the Committee for Control of Science of Education and Science of the Ministry of Education and Science of the Republic of Kazakhstan. And thanks for attention. Sorry for technical problem.
Thank you for your report. So, is there any question? Please. Who has question on you?
I have.
Please, yeah.
So you mentioned that you use gallium as a barrier for oxygen diffusion, right, into your structures.
Yes.
For me, it would be interesting just to check this element, since it's quite expensive. Do you have some other alternatives which could work?
Yes, I know some other alternatives. There are a sufficient number of scientific works on anti-corrosion and graphene coatings in which graphene is doped with boron, nitrogen, and indium. Its elements are 3rd and 5th group, and gallium is a 3rd group element. And I want to yes. I want to do the experiments with gallium because it's a 3rd group element, because we have a lot of with nitrogen, indium, and boron, and we have in our laboratory gun with gallium ions. Yes, and we have a feature, or was more, we have a opportunity, yes, to do it.
Mm-hmm. That means you don't have any opportunity to use this gun, for instance, for boron and nitrogen you mentioned right now. But
yes, yes.
as an expert, for instance, in this field, what do you think? What element would be quite, for instance, plausible in order to use it in the industry, for instance, yeah, for large-scale production or in the real?
Doped element?
Yes, for instance, instead of what would you
I think
suggest?
boron, because it's cheaper. Yes.
Mhm.
And we have a lot of scientific work in boron, and I think this element is yes, we can use.
And you think that boron could be better for industrialization and for large?
For large scale, but why we used gallium? Because I did a computer simulation, and in the work I showed that gallium is able to protect the surface even in the case of sufficiently large gap at 0.45 nanometers. What? That's why I used it.
This gallium element, especially that it has a specific ionic radius, right? In order to
Yes.
graphene, and then it can actually somehow penetrate your electronic states of your graphene, and then this way you can somehow protect your material.
I demonstrated in the presentation.
Okay. Thanks for your answer.
Yes, I did demonstrate this answer.
So another question?
What?
Is there any other
I can show this case. This reconfiguration of gallium atoms.
Mhm.
You can see it in the slide.
Okay, thanks.
Thanks.
So next question,
Yeah, may
please, Didarya.
Yeah, thank you. First of all, thanks you for your presentation. Very good scientific results and very interesting topic. I have a question about your computer simulation when you use the DFT model. So, and there is my question: what is the size of your units? How many elements in your units?
How many elements?
Yeah, how many elements in units?
No, how many elements I simulate? I was simulate. I simulated various kinds of protection. I simulated graphene and oxygen molecules when they approaching to the plane of the graphene plane. When the gap, when the oxygen penetrates directly through graphene sheets, and in the zone zone between graphene and copper surface. A lot of
so
cases, a lot of cases, not a lot of elements, but a lot of cases with the vacancies. Graphene was with vacancy, the vacancy with gap, with gap.
So what is the optimal distance between the vacancies? How did you estimate this? Did you get this concept in your investigations?
I did graphene plane, and
because this is also the very interesting question. Because I see this is a very interesting results, and in the future maybe it will be also in different research direction for your investigation.
Yes, it is interesting. Yes, direction. Yes.
Okay, and my final question about your experimental work. So you mentioned that your number 3 division that ratio between the D peak and G peak should be equal to the some point,
No, yes, it's
0.08 and
it
something.
shows that the graphene which
So-
obtained CVD graphene. What? Sorry.
Okay, so the thermal penetration is blocked when your quality of your structure is increased, right?
Yes,
I
yes,
understand.
yes.
But if you will do some vacancy in this, how it can be change of your ratio?
You know, when your coating have a lot of defects, it's bad to your protection properties.
Anti-corrosions.
Yes, to anti-corrosion properties.
So you have
then
two tools, right?
what?
You have two tools, right? Two instruments how to control your anti-corrosion properties, right?
Yes, yes.
Okay, thank you.
Thank you.
Thank you. So, is there any question? So, if not, let's continue.
May I ask you? Sorry.
Okay, please.
Hello.
Hello.
Thank you for your report. And I have a question about simulation of OG spectrometer. You showed us picture when about energy distribution and energy resolution, and my question is, how did you calculate this property? Did you calculate distribution of electrical field, and then did you solve some equation of motion? In which way did you simulate energy resolution of OG spectrometer?
I didn't simulate.
Sorry.
You tell about resolution, yes? How I
Energy resolution and about distance, not distance, about energy resolution of spectrometer, OG spectrometer.
Я решала. I calculated the equations.
So you were calculating some kind of Newton equation, equation of motion.
It's a calculation. It was a calculation, not simulation.
Okay, it's
Yes.
between calculation and simulation, very small difference.
Yes, I calculated K parameter. It's big questions, and then I calculated resolution. I had to find K parameter, then I need yes to calculate resolution of OG spectroscopy.
Arkady
I was
Mikhailovich
in
is
MATLAB.
agree with you.
MATLAB. Yes.
Using MATLAB.
MATLAB.
Okay.
Yes.
And am I right that firstly you calculate electrostatic field of conical spectrometer, and then you were calculating trajectory using MATLAB and solving numerically equation of motion.
I need to think.
Okay. Yeah. Malika, and did you program numerical scheme, or did you use MATLAB in internal program for solving equation of motion?
I used Runge-cut method.
Ah, Runge-cut. Okay. By the way, of which order? If you mentioned Runge-cut method, which order was this?
Second order focusing.
Second.
Yes.
Okay, thank you. Thank you very much.
Thank you. So, if no questions, let's continue. Next floor is for a local scientific consultant, Doctor of Physical and Mathematical Sciences, Professor of Al-Farabi Kazakh National University, Ilyan Arkady Mikhailov. Please. Arkady Mikhailovich, where are you?
Sorry, I meant.
For order.
Please.
Could
Sorry.
I make my review in a short variant?
Yeah.
Okay. Corrosion of metallic materials is a great economic and environmental problem of our time. When metallic materials and products are exposed to aggressive environmental factors, their performance characteristics deteriorate or even collapse occurs, which can lead to large economic losses. To solve this problem, Nobel Prize winner Novoselov proposed the use of graphene nanostructures as a very effective ultra-thin anti-corrosion coating. Graphene nanostructures show excellent protective properties due to their chemical inertness and impermeability to standard gases, including even helium, chromigelia. However, obtaining the perfect graphene film of large sizes on an industrial scale has certain unresolved technological problems. These problems can be circumvented by replacing graphene with functionalized graphene nanostructures. Small pause. One of the most prominent representatives of graphenes is graphene oxide, GO, which is easily enough applied to various surfaces, which is a great advantage in coating technologies. Thesis work of Tulugenova Malika is devoted to theoretical and experimental studies of the coatings. The theoretical part includes the computer simulation of graphene nanostructures, as well as calculating the effectiveness of their anti-corrosion properties using the first principles methods. During the experimental part, the anti-corrosion protective coatings based on graphene nanostructures were obtained. When performing this thesis work, Tulugenova Malika developed a specialized Ager analyzer, which have a significant novelty in the present work for nanotechnologies. Thesis research of Tulugenova is a well-structured, coherent, and complete work. According to the results, it was determined that the anti-corrosion protective coatings based on graphene nanostructures show high efficiency, which is of great practical interest for industrial, shipbuilding, oil and gas, and other companies. This specialized Ager analyzer developed in a process of the thesis work has an important scientific and practical significance. Thanks to this method, the sensitive analysis to the light elements, I mean carbon, oxygen, nitrogen, within near those layers is not only the coatings based on graphene nanostructures, but also other materials became possible. Results of the thesis work, it is not. Tulugenova Malika showed curiosity, responsibility, diligence, and independence during the performing this work. her demonstrated personal qualities have contributed to the successful accomplishment of her tasks, which shows her to be a qualified specialist in her field. Tulugenova Malika is able to independently conduct theoretical and experimental studies of anti-corrosion protective coatings based on graphene nanostructures. Given the above, I believe that the level of results obtained in the thesis work, the personal qualities of the applicant, the thesis of Tulugenova Malika Askarovna, consistent with the qualification requirements for the thesis for the degree of PhD, and Tulugenova Malika Askarovna deserves a PhD in specialty material science and technology of new materials.
Thank you very much.
Ilyin Arkady Mikhailovich.
Thank you.
Okay.
So next is a foreign scientific consultant, professor of Texas State University, Gary Bill. So he's not able to attend. So review of the scientific consultant will read by the scientific secretary. Please.
Thank you. Dear members of the dissertation council, let me read briefly the review of the foreign scientific consultant. Thesis of Tulugenova, anti-corrosion protective coatings based on graphene nanostructures, is devoted to the theoretical and experimental studies of anti-corrosion protective coatings based on graphene nanostructures. Tulugenova had a scientific internship from June 15 to September 15, 2019, and my supervisor at Texas State University, San Carlos, Texas, USA. During the scientific internship, Tulugenova performed experimental work on the topic of her thesis. Tulugenova perfectly coped with the tasks assigned to her. Also, during the thesis work, she showed such personal qualities as responsible, attuned to work, attentive, and independence. The thesis research has a well organized logical sequence and so films, which is confirmed by well-structured foreign and complete work. As scientific supervisor of Tulugenova, given the above, I believe that the level of results obtained in the thesis work, personal qualities of the applicant, the thesis work of Tulugenova Malika, anti-corrosion protective coatings based on graphene nanostructures meets the qualification requirements of international standard for PhD, and I strongly portray it for submission to the thesis board of your university, and it's after received a PhD degree of specialty 60.071.000 material science and technology of new materials, Professor Gary B.
Thank you. So next words is for reviewers. First official reviewer, PhD coordinator of the research infrastructure of the shared office of Nazarbayev University, Arbuz Alexander, please.
Can you hear me?
Yeah. This.
Okay. Should I read all the review, or I can I can say some summary, and we will continue.
Yeah, summary is enough, I think.
Okay, so let's a little bit less formal summary. Okay, so I have meet in details to this thesis work, and I think that I can consider that this work have good relevance in the discourse of all of modern scientific trends. And now we can see the next stage using of nanoscience, the development of nanoscience and using of nanomaterials, much more practice, and this is really nice, just because the corrosion, just general topic of corrosion is one of most relevant topic of material science. I mean, the field of constructive materials, the field of functional materials, the corrosion protection have a increased value, and due of it, using the graphene, this direction is a really good idea, and so we can see the well and good organized research process with according to all rules of proceeding, and the thesis work have normal internal unity. All of points inside of thesis is well justified, and the purpose and tasks also correspond to the topic of thesis. I think that all of us can see it during the presentation. So, and the main provisions of this work is proven by deep theoretical and experimental work. So I think then I consider that based on this work, I can recommend to award the Doctor of Philosophy degree to Miss Tulugenova, and will name to Dr. Tulugenova. That's all from my side. The detailed copy of review with all of points regards to Kazakh National University rules. You can find attached to all of documentation. And from my side right now, I have no significance questions. Of course, each work so I think that now I can finish.
Thank you. Do you have any comment for dissertation work? So is there no any comment there? Okay. So next official reviewer is PhD Associated Professor, Vice Rector for Science and International Affairs of International University of Information and Technologies, Evgenia Dainenko, please. Where is you?
Good day, dear colleagues, dear members of the Dissertation Council. Let me introduce the review on the thesis work of Malika Tulegenova. And I would like to mention only the, the main criteria of the work, if you don't mind, and the summary, of course. So the theses of this work correspond to the priority directions of science development and the state program in the field of material science. This work makes a significant contribution to science, and the results obtained are new and of interest in physics of nanomaterials and material science. The importance of the thesis work is well disclosed by the author and lies in the demonstration of the effectiveness of anti-corrosion protective coatings based on graphene nanostructures. The relevance of this work is significantly justified. The thesis work is devoted to the theoretical and experimental studies of the anti-corrosion protective coatings based on graphene nanostructures. The relevance of the work is well disclosed in the introduction and is mainly related to the use of coatings, which should demonstrate reliable protection of metal surfaces. The purpose and the task of the research correspond to the topic of the thesis. The purpose is set in such a way as to give an understanding of the main directions in which the author reveals the topic of the thesis, and the task in turn give an understanding of the main stages of the research work. New solutions proposed by the author consisting in the development of technology for obtaining and research for effectiveness of anti-corrosion protective coatings based on graphene nanostructures are reasoned and evaluated in comparison with well-known solutions. The scientific results and the main provisions for the defense are completely new. Technical, methodological, economic, and management decisions are new and reasonable. Based on the thesis materials, 11 publications were made, including 3 articles published in journal recommended by the Committee of Control of Education and Science, and 3 articles were published in the journal, which include in Scopus database. So the choice of methodology is justified by the modern generally accepted scientific theories of solid-state physics and spectroscopy. The general methodological basic of the thesis is a comprehensive approach, including analysis and generalization of fundamental research. As a result of the thesis work, we obtained using modern methods of scientific research and experimental data processing. Technology of obtaining graphene nanostructures by chemical vapor deposition, obtaining graphene nanostructure by the diffusion methods under vacuum conditions, obtaining graphene oxide films were carried out on the basis of experimental facilities. Thesis has a theoretical and a practical importance, and they have the high probability of applying the results obtained and significant problems, especially which can be applied in the industry. The methods for obtaining and studying ultra-thin corrosion coatings proposed in this work are completely new and can contribute to the advancement of the research in this direction. So the main conclusion, the main summary for the review, thesis work performed on the topic anti-corrosion protective coatings based on the graphene nanostructures is a completed research work which, due to its scientific novelty and practical significance, meets all the requirements of the rules of awarding the degree of Doctor of Philosophy of the Committee of the Quality Assurance in the Field of Science and Higher Education of the Ministry of Science and Higher Education of the Republic of Kazakhstan, and its author, Tулегенова Malika Askarovna, deserve to be awarded to the degree of Doctor of Philosophy in the specialty 6D07100 Materials Science and Technology of New Materials. Thank you.
Thank you. So, if there are no any comments, we will continue.
So no comments from my side.
Yeah. Thank you very much. Next stage is discussion. So, who wants to support or make some comments to dissertation work on our discipline? Please. Floor is open. Who wish to support?
Sorry, question was stand like who is willing to support and nobody responds. So I would like to support this thesis, and my opinion is that I totally agree with the talk of consultant and with the opinions of official reviewers, the both of official reviewers. So I would like to support Ms. Malika Askarovna, and I think that we should, how it is official, but to what we should do with degree. I forgot this word in English. So I have also positive opinion about her work, and I ask my colleagues also to vote for her degrees. Thank you.
Thank you very much. So,
I'm also definitely want to support this PhD thesis, and I think that the topics of, as I mentioned before, the topics of the dissertation is very actual and very interesting, and the candidates of the PhD degree, she answered to all my questions and to the questions of other my colleagues. And also, in my opinion, the candidates have all the knowledge how to organize this such kind of research work. And also, in my opinion, I see a lot of additional directions for the future researchers. So I think Tулегенова Malika will in the future increase her research to open a new knowledge in the direction of this interesting task of anti-corrosion films, which is obtained with different kind of functionalization process of graphene materials. So I also ask other colleagues to vote for supporting this. Thank you.
Thank you very much. So maybe another?
Yeah, I just want shortly to mention that not many groups actually work on graphene materials in Kazakhstan, right? And as far as I know, it's also one of the first group who has actually started this development, this material production in Kazakh National University. And I think that one should support such kind of nice direction, especially these 2D materials, which are very popular nowadays. And I think that in Kazakhstan, we try to develop this technology. We try to implement, and hopefully also in the industry, if one could also produce this in Kazakhstan and export it to another countries. And since we have a lot of resources in Kazakhstan, I think that it's actually a nice direction. And I'm happy to see that people work on this material modeling and also production and synthesis. So Malika, I support. I think that it's nice to see. Thanks.
Thank you very much. So I think it's enough. So I wish also support you, Malika. It's a very good work. And I hope that you will continue your work, and I wish to work hard because it's very actual and very heartfelt, and you need in very good equipment for making some achievement. So in any case, I hope that you will be very valuable member of your team, and you will work with our professors, and in future you will be one of point of growing our specialists, our faculty specialists. So I invite you to work in Al-Farabi Kazakh University and make some success for our groups and our laboratories. So also I beg all of our members to support her. So thank you. So let's go to the next stage. This is after a discussion. So we can give a closing speech to our applicant. Please, Malika.
Thank you for all your support. I'd like to thank all participants and members of the dissertation council for the constructive questions and interesting discussion. I want to express my sincere gratitude to my supervisor, Irina Arkady Mikhailovich, for the years I spent under his supervision, for support and participation in my work, as well as to my foreign supervisor, Gary Bill, for his cooperation and for the opportunity to work in the laboratory of Texas State University. I also want to express my great gratitude to my colleagues from NNLOT Nanolaboratory and to my family, in particular to my husband. Thank you. Thank you.
Okay. So next stage is a secret voting. So for conducting this procedure, the floor is given to the scientific secretary, Farida Belisarova. Please.
Dear members of the dissertation council, a voting ballot has been sent to your mail. For secret voting, please vote. 10 voices. Video Janic. I asked for emission to publish the results of the secret voting. All members of the dissertation council voted. Results of the secret voting were in the degree of Doctor of Philosophy 12, sending the thesis for revision 0, sending the thesis for defense 0, refusal to award the degree of Doctor of Philosophy or Doctor of Profile 0. They are certified by an diagram document.
Okay, so we can congratulate. So let me to constate that dissertation council on the group of specialty physics, nuclear physics, technical physics, physics and astronomy, radio engineering, electronics and telecommunications, material science and technology of new materials, thermal physics, thermal power engineering, physics, standardization and certification by industry at Al-Farabi Kazakh National University. For award of degree of Doctor of Philosophy, PhD, to Tulugenova Malika Askarovna in specialty 6D07 1000 material science and technology of new materials. Congratulations. So you can congratulate our applicant. She already PhD. So my congratulations. Farida Beksultan. So is it necessary to make conclusion or not? So it's new rules, that's why it's not necessary yet. So in that case, let me to close this meeting. Thank you very much to all participants. Goodbye.
Thank you.
Thank you. Goodbye. My congratulations.
Thank you
Congratulations.
very much. Congratulations.
Thank you. Thank you.
Arkady Mikhailovich, congratulations.
Огромное спасибо, Женя. Правильно, правильно, Женя.
Малика, поздравляем.
Молодец, молодец.
Спасибо
Малика.
большое. Спасибо. Спасибо за поддержку.
До свидания.
За все, что участвовали.
Алга, Малика. Отдыхай теперь.
Да, спасибо.
Молодец, молодец. Это не на каждой защите такое получается. Не на каждой, я тебе говорю точно. А у тебя получилось.
Спасибо, Аркадий Михайлович.
Это важно.
Спасибо.